Now, before we start on today's lesson, are there any questions over the homework? Yes? Well, that makes it a little bit easier to solve. You're welcome. Now, so we have this here. So we want to find the x-intercept, which is our p and q value. So one of them, and the other is 3. So there's always going to be 2 x-intercepts. The only way we'll have one is if it's the same intercept. It's just a point.
Okay. And then how do you find the vertex?
So the vertex is our p plus q over 2. Well, that'd be negative 3 plus 3 over 2, which is 0 over 2, or just 0. Now to find the y value of the vertex, we plug it back in. So it would be 0 plus 3 times 0 minus 3. Well, 0 plus 3 is 3. 0 minus 3 is negative 3. The axis of symmetry, x is equal to 0. X is equal to our p plus q.
So how did you find the vertex in? So p plus q
over 2 comma f of p plus 2 over.
What is f of?
We just plug it back in.
Oh.
Over 2. Any other questions on the homework? Now this is the first one we're going to look at. Now we are skipping a few. We will have time tomorrow. We'll look at least one of them tomorrow. But the other half of the homework is identifying the vertex, focus, directrix, and axis of symmetry. 2, yes.
Did we skip 2.31?
Well, yes and no, because we're going to still do it. We're just doing this one first. H, K, and P. We need to find these 3 values, because if we know these 3 values, we can find the vertex, axis of symmetry, focus, and directrix. Because all of them, the vertex is H comma K. The axis of symmetry is either x equals h or y equals k, depending on which equation we have. The focus is either h comma k plus p or h plus p comma k, again, depending on which function we have. And the directrix is either x equals h minus p or y is equal to k minus p. But in any case, we need to find the values of h, k, and p. So let's line them up. So it would be y equals 1 over p times x squared plus k. Now looking at this here, our k value is 2, because our plus k plus 2. So our k value is positive 2. What would the value of h be? It would just be 3, because it's inside. We have x minus 3, x minus h. Everything's the same. X is the same minus the same, so the value of h is just 3. Questions on this here? Any questions on how we found the values of h and k? Now, in all the ones we've done up to this point, finding the value of p, we had to do some calculations to find it. The same is true for this here. So our 1 over 4p is where the p-value is located, yes? What is taking its place in our equation here? 1/8. And really, yes? So our 1 over 4p, whenever we plug whatever the value p into it, we should get 1 over 8. So our 1 over 4p is going to equal our 1 over 8. Questions on how we set this up? So really, whenever we're finding the value of the vertex, axis of symmetry, or focus, to find the value of p, we're going to set that 1 over 4p equal to whatever the number is in front of the parentheses, in front of that variable being squared. Now the next part is going to be the same as well. We're going to multiply both sides by 4p. Now I'm going to write this out all the way. We're not going to do this fully written out every single time. Because if we multiply both sides by 4p, the 4p will multiply with the numerator, giving us 4p over 4p. On the other side, we would get 4p over 8. Well, 4p divided by 4p, anything divided by itself is 1. Now 4p over 8, the 4 over 8 reduces to 1 over almost 2. Because 4 over 8 is the same as 1/2, so p over 2. Questions on this so far? Then we multiply both sides by 2 to get p by itself. Yes. Questions on how we found the values of h, k, and p? Now, if you're not sure you got the right value of p, we can plug it back into our 1 over 4p. So in this case, it'd be 1 over 4 times 2, which is 1/8, which does match up what we got. 1 over 4 times 2. Because if we're checking it, we're plugging it back into our 1 over 4p. Questions on any of this here? No. Because what we're trying to find is the vertex, which is our point h comma k, our axis of symmetry, which in our case is x equals h, our focus is the point h comma k plus p, and the directrix is the equation y equals k minus p. And again, I got all these just from the equation here, our standard form. You're good. Now the first thing we're going to find is the vertex. Our vertex is what? H comma k, yes? What's the value of h? And the value of k is? So the vertex is the point? 32. Our axis of symmetry is the equation x equals h. So x equals 3. Now the focus is h comma k plus p. Well, h is still 3, but we do need to calculate k plus p. K is 2, p is 2, and 2 plus 2 is. And lastly is the directrix, y equals k minus p. Now we do need to calculate this, so k is 2, p is 2, and 2 minus 2 is? That's it. Because once we found the values of h, k, and p, we can find the information we need. Questions on this here? Now looking at this here, we can get the entire vertex axis of symmetry in half of the focus just by the values of h and k. There's only two parts that we need the value of p for. Let's look at the next one. They are not. I believe the one after this is x equals. So y equals negative 1/4 times x minus, or x plus 2 squared plus 1. So this is our y equals equation. We'll match it up with this here. Now we do need to find the value of h, k, and p. Now looking at this here, what is the value of k? 1. What's the value of h? Negative 2. Because since we have plus 2 in the equation, it's going to come out as negative 2. Yes. Now, if we were calculating out to find p, we would set 1 over 4p to our negative 1/4. Now, there are going to be some of these for finding the value of p. You might be able to see them, look at it, and be able to determine what it is. If not, that's fine, because we can set it up. The number that takes the place of 1 over 4p, the number in front of the parentheses is negative 1/4. So we'll set it equal to 4p. And again, we're going to multiply both sides by 4p. Now, 1 over 4p times 4p, well, the 4p and 4p will simplify to 1. They will simplify out. Now, on the other side, our negative 1/4 times 4p, well, we'll still have the p value, but we're going to do what? Negative 1/4 times 4. We're going to multiply those two numbers together. So negative 1/4 times 4 is negative 1. So it's negative 1 times p. Or we can just say it is negative p. Because we don't necessarily need the 1, but it's understood if we don't write it. What's the last thing we need to do? Turn it into a positive. We can multiply both sides by negative 1. Negative 1 times negative p is, so p is negative 1. Vertex is the point h comma k. Well, our h value is what? Yes, and our k value is 1. Axis of symmetry. X equals h, so x equals negative 2. Focus is our h comma k plus p. Well, the h value is still in our p value. So our k plus p is what? 1 plus negative 1. And 1 plus negative 1 is 0. Our directrix is our y equals k minus p. K is 1, p is negative 1. So our equation is y is equal to 2.
So sorry,
You're good.
I was yawning and it just came out. I'm so sorry.
A spasm of the diaphragm.
What's happening all together?
So this is 1 through 4.
Yes.
Okay.
Questions on these here? Questions on any of these here so far? Let's look at the next one here. Now this one is x equals, so we'll have x equals 1 over 4p times y minus k squared plus h. Now we still need to find the values of h, k, and p. Now looking at this here, what would the value of k be? 3. And h would be 1. As if you notice for this one here, k is now inside the parentheses and h is outside. So whenever we do have x equals, we do need to make sure that we get h and k from the correct locations. Now we're also saying 1 over 4p is taking the place of what? 1 over 16. Questions on how we found h, k, or set up our equation to find p. So what would we do next? We'll multiply both sides by 4p. Now on the left-hand side, the 4p and 4p will simplify to 1 equals. So we're going to do our 4 times 1/16, yes? So 4 times 1/16 is 1/4, or we can say that it is p over 4. Now what would we do next? Okay, since we have p divided by 4, we would multiply both sides by, telling us p is. And if we wanted to check this, we could say 1 over 4 times 4 is indeed 1/16, just like we started the equation with. Now the first thing we want to find is the vertex. Well, the vertex is what? The point h comma, what's the value of h? And the value of k is? Now our axis of symmetry. So for this one, we have y equals k. So this time y would equal 3. The next one we're looking at is the focus. So h plus p comma k. Well, k is still 3, but we do need to figure out what h plus p is. Well, h is 1, p is 4, and 1 plus 4 is? And this x is equal to h minus p. Well, h is 1. Okay. What did you get H as?
Net 1,
K.
minus 3, P. I haven't got that far yet because 6 for P. Well, I did something wrong.
So the one you're looking at, so we can check it. We can say 1 over 4 times 6, yes? 1 over 24, but we want
3 over 2. I got a weird fraction. So I did 2 over 12
what fraction did you get?
is, oh, is it 1/6?
So you did 1/6. So let's try 1/6. 1 over 4 times.
I did it something wrong.
Yeah, I didn't go down. 1 over 4 times 1/6 is.
Okay, so it is. I don't get that part. I did.
On that one there, getting P.
Yeah, just in general.
So we can look at this here, and I think it might answer it because we're looking at it in a similar way. Now the general form is y equals 1 over 4p times x minus h squared plus k, yes? Now we need to find the values of h, k, and p. And I think we feel comfortable with h and k because this one here, k, is -5. H would be -3 because +3 on the inside would come out as -3. Now the value of P, well, when we looked at the equations and we plugged the value in and simplified, this 1 over 4P turned into whatever number was in front of the parenthesis. In this case, it would be 1 because it's not written, so it's understood to be 1. So we're saying that whatever P is, when I plug it into 1 over 4P, I should get 1. And in the first problem on the homework, we wouldn't put 1, we would put 3 over 2. Now, no matter what the problem is or how it's set up, the first step is to multiply both sides by 4p. Because the left-hand side here would 4p and 4p would simplify out, leaving us with 1. On the other side, we're going to do 1 times 4p, which is just 4p. Now to simplify this here, we need to divide both sides by 4, because 4p divided by 4 is just p, and 1 divided by 4 is, so the value of p is right there. So p is not restricted to be a whole number like most of them have been. We can have fractions, and that's just fine. Questions on this here? Yeah. Yeah, you're right there. How would we get p by itself? We would. Now the vertex is our point h comma k. So what's the h value? The k value is? So the vertex is -3 comma -5. Our axis of symmetry for this here is x equals h, and the h value is? Our focus is the point h comma k plus 3, and again, I'm just pulling these from our general form, which would be -3. Now k plus p would be -5 plus 1/4. Now I can't say this is just -5 and 1/4 because one of them's positive and the other's negative. So as a mixed number, it's -19/4. Or if we wanted this as a decimal number, that is negative 4.75. Or as a mixed number, it's negative 4 and 3/4.
I don't know where I messed up on number 2 either, but I messed up on because back in 3 was I got negative 1/4.
And the the value in front of the parentheses was not negative 1, was it? Because you got p as negative 1/4,
Yeah.
which would have given you negative 1 when plugged back in, yes?
Negative 1, yeah.
But that's not what we want.
Yeah. So that's where I knew it was wrong. But
Multiplied by 4p.
is it not negative 4p? Is it not negative 8?
That's 4 times negative 1/2.
Negative 2? Okay, so I just flipped it to the negative instead of positive. So just calculate it.
Yeah. Now, looking at this here for the y value of the focus, any of these work. You just got to pick one. Now, the directrix, y is equal to k minus p. So k minus p would be negative 5 minus 1/4, which if we plugged it into a calculator would be negative 21/4, or negative 5.25, or negative 5 and 1/4. Questions on these here? Questions on anything we've done so far? We ready for one more? I'm trying to remember what was after that one. There you go. Let's look at this one here. Now, this one's a little bit different than the ones we've had so far because the number in front of the parentheses is not a fraction, and it is negative. So x equals 1/4p times. I mean, yes. We can put it over 1, but we don't necessarily need that. But we still need to find the values of h, k, and p. Now, looking at this form, what is the value of h? X equals is the other way. Now, our value of k would be now for this one here, our 1/4p would be set equal to what? Because what's taking its place? Negative 3. So we're going to say 1/4p is negative 3. Now at this point here, to get p by itself, we would multiply both sides by 4p. Now over here, the 4p and 4p would simplify out to 1. Now on the other side, we have negative 3 times 4p. Well, negative 3 times 4 is negative 12p. What do we need to do to get p by itself? We would Divide both sides by negative 12, telling us P is negative 1/12. Now, if we want to verify this is the correct value, we can plug it back into our 1 over 4 P. So 1 over 4 times negative 1/12, which is negative 3, which is the exact value that we wanted. So now we just need to find the vertex. Well, our vertex for this form is the point h comma k. Well, our h value is, and our k value is negative 4. Axis of symmetry for this here is y equals k, and our k value is negative 4. Focus. Our focus for this one here is h plus p comma k. So the k value is going to stay negative 4, but we need to determine what h plus p is. Well, h is 2, and p is negative 1/12. So we'll need to do 2 plus negative 1/12, which is 23/12. And lastly, the directrix. And this is our x is equal to h minus p. So 2 minus negative 1/12. Well, the negative and negative would make a plus. And 2 minus negative 1/12 is 25/12. Questions on any of this here?